4.7, we're going to solve quadratic equations using a technique called completing the square. This technique is used a lot, especially as we move on to honors pre-cal and calculus. So what that really means is we're going to try to rewrite one side of the equation as a perfect square. Turns out this one works out nice. This is x squared and 4 squared, and the middle matches up. 2 times x times 4. So we can write this as x minus 4 squared. Now we can solve this by taking square roots of both sides. Before I do that, let's look at what's really going on. Why we call it completing the square, another reason. You can draw a little 2 by 2 square. We can put our first term here, and we're going to split up our b. Cut it in half, negative 4x and negative 4x. And then we'll say, okay, what needs to go on the outside? X and x. X times what is negative 4x? X times what is negative 4x? And fill in that last piece. Negative 4 times negative 4 is 16. This is why this is called a perfect square, because we put the same thing on both sides. As you can imagine, that's not going to happen in every single problem, but we're going to manipulate the problems to make it work out. But first, let's finish up this problem. We take the square root of both sides, plus or minus 5. X equals 4 plus or minus 5. And we know what 4 plus 5 is. 9. We know what 4 minus 5 is. Negative 1. And we've got our answers. We didn't have to set the whole thing equal to 0. We didn't have to use Clinton magic even. This slide kind of explains completing the square. I don't like the way it explains it, so I'm not going to spend a lot of time talking about it. I'll show you how to complete the square. So we want to find the value that makes x squared plus 16x plus c a perfect square trinomial. We start by drawing our little square. We know we're going to have to put 16x, or we're going to put x squared here, and an x and an x. We take that middle piece, 16x, and split it into these two boxes equally. That tells us to put our plus 8 and plus 8. Now we know what number has to go in the last box, because 8 times 8 is 64. So c equals 64. And then we're supposed to write this expression as a square of a binomial. We can see from our picture that's x plus 8 squared. We can also see that it's x plus 8 squared because we know how to factor x squared plus 16x plus 64. So that's what completing the square looks like. Now we're going to see it in an application where we're solving for x. Before that, pause the video and try these on your own, or you can do that later. So let's try our completing the square technique. We're going to run into a problem. X squared, no problem. Split up the negative 12x, no problem. Minus 6, no problem. We want a 36 there, but we don't have a 36. We have a 4. Not to worry. The way we handle this is we first say, goodbye, 4. I'm moving you to the other side of the equal sign. And in your place, I'm going to put a plus 36. Like we learned in pre-algebra, if we add something to one side, we have to add it to the other. Now we can say x minus 6 squared equals 32. From here, we know how to solve it. Take the square root of both sides, simplify, and so on. Go ahead and pause the video, try that on your own. Make sure you get the same answer as me. And that's it. We solved by completing the square. A little harder in example 4. We can't actually complete the square using the technique I showed you unless a equals 1. So if a doesn't equal 1, just manipulate it. And we can move that 14 over to the other side while we're at it. X squared plus 4x equals negative 7. So from here, try to figure it out on your own. Figure out what number we're going to add to both sides to complete the square. You don't have to draw the box to do it. You should be able to think it through. Once you've got that, solve for x. You should have run into a negative square root in that problem, and we know how to deal with negative square roots by using complex numbers. That's it. Standardized text practice. We're told that the area of the rectangle is 72 square units. What's the value of x? So you're going to go ahead and pause the video and try this. The hint I'll give you, use the formula for area. 3x times x plus 2 equals our total area. You're going to have to distribute. You're going to have to set one side equal to 0. And you're going to have to divide to get rid of the 3. So go ahead and set this equal to 0. I'll put that up before I put up the solution. Once you get this far, you should also be able to make a equal 1 by dividing everything by a certain number. Try that. We'll check in again before I put up the final answer. From here, I made a little mistake myself even. We don't want to factor this to get the answer. We want to complete the square. So we keep that 24 over there. We should know how to complete the square from here. Turns out factoring works too, but let's practice completing the square because that's what the name of the game is today. Trickery alert. If you choose choice D, you're wrong. X cannot be -6 because you can't have a negative side length on a rectangle. So we can only use the 4. At this point, you can pause the video and try these on your own, or you can continue on. Now we get to see why this is super useful. We're going to get not only solving quadratics, we can also put a quadratic in vertex form by completing the square. It's a little different this time. We're not going to put the 22 on the other side. Why not? Because we want to keep y by itself. If we don't keep y by itself, it's not going to be in the right format for us to get vertex form. So instead, we just keep the plus 22 on the outside. We still ask ourselves, what number do we want here? Plus 25. And instead of writing minus 25 on the other side, don't do that because now you've got y not by itself. Instead, ask yourself, what can I put over here to make up for a positive 25? And the simple solution is negative 25. Let's talk about y real quick. What's positive 25 and negative 25 add up to? 0. So what did I really add to the equation? 0. It's just a bunch of filler. But that filler informs us of the vertex. We can now factor this. And we've got our vertex. In fact, we can now draw a quick graph. We know the vertex is at 5, -3. And we know that this opens up. So we get a quick sketch of the graph. In fact, we can go so far as to say we know the y-intercept is 22 because y-intercept is easy to get from that standard form piece. So that's the real power of completing the square. Go ahead and pause the video now and see if you can figure out what's going on here before we talk about it. As you can imagine, this equation is giving us a parabola shape, which makes sense because that's kind of what the height of a baseball does. It starts getting high real fast, then it kind of slows down, hits its peak, and then comes back down. So we really want the vertex of this parabola. We could do that by factoring. We could do that by quadratic formula, which we haven't learned technically in this class. But because we're in the section on completing the square, we're going to complete the square. The maximum height is going to be at the y value of the vertex. So vertex form is great for finding this. It's a little tricky though. Well, let's talk about why it's tricky. We really want to figure out what number to put in the blank and then balance it out over here. Except we can't do that until we factor out the -16. We want a to equal 1. So you have to take out whatever a is first. We end up with t squared minus 6t, and that plus 3 out there. Now you can decide what number to add in there. Hopefully you come up with 9. If you try to balance it out by putting a -9, you actually made a mistake. Let's talk about why. We didn't really add 9. We added 9 times -16, which is 144. So that's really -144 that we just put on this side of the equation. To balance out a negative 144, we put a positive 144. At this point, we can say this is negative 16t minus 3 squared plus 147. Vertex is at 3, 147. What that's really telling us is that 3 seconds after you hit the ball, it reaches its maximum of 147 feet. And that's all it's asking us. At this point, you can pause the video and try these on your own. And other than that, we're done with this lesson.